Hi everyone. Now we shall move on to the next module, that is module 5, which consists of two chapters. One is synchronous generators and another one is three-phase induction motor. So now we shall move on to the first chapter, which comes under module 5, that is synchronous generators. I hope you are already familiar with the concept called DC machines like motors and generators, right? So what are these motors and generators? So let me repeat, the motor is a device which converts electrical energy into mechanical energy. Similarly, the generator is a device which converts mechanical energy into electrical energy. As you see in this particular figure, so we have electrical system here and we have mechanical system. So of course, so there will be a magnetic field, that is there will be a magnetic field which couples, okay, so the electrical system and the mechanical system, that is in motor and the generator. And so you are already aware that the motor and the working of the motor and the generator, so based on the principle of electromagnetic induction. So here you can see the direction. So the device which converts the, already as I have indicated, the magnetic field which couples the electrical system and the mechanical system. So you can see the two directions. So what are these two directions indicate? The device which converts from this electrical system to mechanical system, or from electrical energy to mechanical energy, is nothing but the motor. So this is nothing but motor. And similarly, here you can see another direction which converts, or the device which converts from the mechanical energy into electrical energy, is nothing but generator. In this particular chapter, so you are going to learn about synchronous generator. So what is this synchronous generator? The most commonly used machine which generates electric power, that is AC power, okay. So that is both commercially as well as that is for domestic purposes, or synchronous generator. And the synchronous generator is also called as AC generator, and so it can also be called as alternators. Alternators are generally constructed in large sizes, that is 11 kVA 500 megawatts. Now, so we shall move on to the working principle, or before that the constructional details of the synchronous generator, and followed by the working principle of synchronous generator. And it has got two different parts. Mainly it has two parts. One is the stator and another one is rotor. So you might have heard about the word called stator and rotor in DC machines, right? The stator is the stationary part, rotor is the rotating part. The field winding system is placed on the rotor, armature conductor is placed on the stator. Now we shall look into the constructional details of the synchronous generator. You can see the figure. As I have already told you, so it has got two major parts. One is the stator and another one is the rotor. So this part we call it as rotor, so where it is rotating, and this part is the outer part, is nothing but the stator, and which is stationary. So here, and in this, the core of the stator, so this is the stator part. So as I have already indicated, this is the stationary part. The core of the stator is made up of high grade silicon steel with high permeability, which minimizes hysteresis loss. Already I have introduced the concept called hysteresis loss and eddy current loss in the transformer chapter. So here, so which is made up of high grade silicon steel with high permeability, which minimizes hysteresis loss. And to reduce the eddy current loss, here the core of the stator is made of laminations, and insulated from each other. And these laminations are stamped out on a complete ring for small machines and segments for large machines. And here these stampings have uniformly distributed open slots. So here, so we consider this as these are the stamped out, these are laminated and insulated from each other, and of course these are stamped here to form a complete ring, and these stampings have open slots or uniformly distributed open slots. So as you can see here, so these are the open slots on its periphery, that is inner periphery. Here you can see there are open slots, or we consider semi-open slots on its inner periphery of the stator. You can see here, so here this part is open here because this part we call it as the inner periphery. You can find the open slots or the semi-open slots on its inner periphery of the stator core. So where we can accommodate the armature coil. So remember, armature coil or this coil, we also call it as conductors. So to accommodate the armature coil or conductors, so these are made semi slots or open slots at the on its inner periphery of the stator. And in the construction part, you can see this part is a stator. Okay, so outer part is a stator, and this is stator core. So these are the stator core, and so this portion we call it as stator slot. So what is this stator slot? The slot where we can accommodate the conductors. The slot is made here, that is to accommodate the armature conductors. So remember these circles, as you see in this figure, the circles are armature coil, or we also call it as armature conductors. And here when we come to the rotor, it is a cylindrical structure. The rotor is a cylindrical structure and which can rotate inside. So this can rotate inside the stator with a small air gap. So you can see there is a gap between the rotor and the stator, right? And here, so it can house, or it can houses the field winding. This is nothing but field winding. So we have already indicated or shown here the field magnet, or we also call it as field winding, where we find the magnetic field. And so this part is a rotor, and these are the poles. So poles are arranged, that is north and south poles are arranged alternatively. This winding is excited. How it gets excited? So this winding is excited by a DC generator called exciter, and we also call it as DC excitation or DC exciter. So where it passes the DC through this carbon brushes to the field winding. These are the constructional details. Of the synchronous generator. Initially, the field windings are excited by DC exciter or DC voltage, which is of 110 volts or 220 volts, that is through carbon brushes. So here the flux produced in the field winding which sweep across. So of course initially the rotor rotates by a prime mover, and the prime mover can be considered as water turbine or steam turbine. The flux produced in the field winding, right? So and of course when the poles sweep across the conductor, armature conductor, so EMF will be induced. So in this way EMF will be produced or induced, and that is why it is called as AC generator, alternator or synchronous generator. Here, depending upon the type of the prime mover, okay, so which is used to drive the alternator, there are two types of rotors. So one is, the first type of rotor is the smooth cylindrical or non-salient type. The first type is smooth cylindrical, or we also call it as non-salient type, and the another type of rotor is salient type. Okay, the meaning of salient is projected. And this is the figure of non-salient type. Why it is called as non-salient? As I have already told you, salient means it is projected. Here the poles are not projected. See here, if I don't mention N and S, you cannot say where is the pole. So that is why it is called as non-salient. So poles are not projected or poles are not seen here, right? And you can see here, so there are four poles in this type of rotor. So 4 poles, north, south, because there are 2 pair of poles, so north, south and north, south. So there are 4 poles, and so there are 3 slots per pole. As you can see in this figure, so there are 4 poles and there are 3 slots per pole. If I consider only for this particular pole, that is per pole, you can see 3 slots over here. So this is 1 slot, right? So 1, 2, 3. So there are 3 slots per pole, and there are 2 conductors per slot. So remember, there are 4 poles and there are 3 slots per pole, and there are 2 conductors. So these are the conductors, and we also call it as field winding. As I've already explained you in the working principle or the constructional details of the synchronous generator. So the field winding system is placed on the rotor. So we call this as field winding, or we also call it as field conductors. So you can see only 2 conductors per slot, because this is nothing but a slot where we can accommodate the conductors or the winding, and there are only 2 conductors per slot. And as I've already explained you, the rotor is made of laminations so insulated from each other. Of course, all these are stamped together to form a complete cylindrical form. And in this type of rotor, the rotor rotates in vertical axis. So here it exerts centrifugal force on conductors. Therefore, to reduce the centrifugal force on conductor, the cylindrical rotor the diameter of the cylindrical rotor is made small, and the axial length is made longer. So this is all about the non-salient type or the smooth cylindrical type. And here, so the advantages of non-salient type is used in thermal or nuclear power station, and the prime mover used is thermal turbine, preferred for high speed alternators. Remember, the main application or the advantage of this non-salient type is it is preferred for high speed alternators. Because of the smooth surface, it has less winding loss compared to another type of rotor. And the next type of the rotor is salient type. As I have already indicated, salient means it is projected. So you can just compare this figure, the given figure, with the previous figure. Earlier in the previous figure, that is in the non-salient type, the poles were not projected, the poles were not seen, but here the poles are projected. So that is why it is called as salient type of rotor. Okay, so the same figure which we have already seen, the same type of rotor which we have already seen in the constructional details of the synchronous generator. So these 4 are the poles, and of course it houses the field windings. So you can see here the field windings are wound on the poles, and this is called shaft. So where we can place the prime mover, or where we can have the turbines, different types of turbines. And here there are some advantages of salient type. So that is used in the salient type of the rotor is used in hydroelectric power station. And this hydroelectric power station operate best at relatively low speed. So the earlier one, that is non-salient type, it works with the previous one, that is a non-salient type. So it works with the high speed application, and this is meant for low speed application. So, and for low speed, it is required to have more or the large number of poles. So remember, for low speed, it is required to have large number of poles, or to have the large number of poles, here the diameter of the cylindrical rotor, or the diameter of the cylindrical rotor is made so larger, and the axial length of these poles are made smaller. In order to accommodate the large number of poles, the diameter of the cylindrical core is made larger, and the axial length is made smaller. And of course, here you can see the tips are rounded here. The pole tips are well rounded so as to make the flux distribution, nearer to sine wave, which improves the waveform of the generated EMF. In this session, you have learnt about the constructional details, working principle of the synchronous generator, and the different types of rotors called non-salient type and salient type. Thank you.